Hello everyone, welcome to my YouTube channel Double E Academy. So myself Vinay BK. Without wasting time again, we'll go for the second problem of mesh analysis. That is kind of different problem. We can also call that as super mesh analysis problem. I'll write again if you want super mesh analysis problem. So why I'm calling this as a super mesh analysis means there is a current source in any one of the branch. If there is a presence of current source in any one of the branch, then you can call that circuit or then you can call that analysis as super mesh analysis. Okay. So now consider this problem. So what they ask to find all the branch currents. So you need to find all the branch currents with the help of super mesh analysis because there is a current source. Steps are very simple. Whatever the steps we solved in a previous video, so I explained one problem with the help of mesh analysis with the step by step in a previous video. Just go through that video, you'll get to know the steps. Just follow that steps. Just I'll remind what and all the steps we followed to write the equations with the help of KVL by using mesh analysis as well as super mesh analysis in this problem. So first step, whatever as I told, first step I'm just naming here. There are nodes A, B, C, D, E, F, G, H. So there is a current which flowing from H to A. That is nothing but you just neglect that. First you write what letters or else namings. Once after that give loop direction along with the current. So I1 is flowing here. Three loops are there. Similarly I2 is flowing here. Similarly I3 is flowing in this direction. Here I3 is flowing. I3 is flowing here. So what you can observe with the help of this circuit, I1 is nothing but consider a loop A, B, G, H, A. Steps I explained in the last video, that is nothing but first give namings, then give loop direction along with the current if they are not given. If they are given means you can use that loop direction along with the current only. So here I am giving three loop direction along with the current, that is I1, I2, I3 because it is having three loops. Clear? So in the first loop we can see there is a current source. I1 is flowing. So without doubt I'll write here in a loop A, B, G, H, A. In loop 1, I1 is flowing. That is nothing but 1 ampere of current is flowing. That is nothing but 1 ampere of current is flowing. So here. So I1 value is 1 ampere. So you already know the loop current. So that the rule for the super mesh analysis that where there is a current source, you just neglect that loop. You are not considering that loop. If there is a current source, neglect the mesh or else neglect that loop. So in the loop A, B, G, H, A, I1 is flowing, but there is a current source of 1 ampere, so that you already got to know the value of one loop current. Similarly, you need to find other two loop currents, that is nothing but I2 and I3. So that neglect loop 1, loop 1 is neglected. Apply KVL to loop 2. Apply KVL to loop 2. So what is loop 2 here? So loop 2 is nothing but B, C, F, G, B. Clockwise direction along with the current I2. So what steps I told in the last video, that is first give names, then you give loop direction along with the current, then mark the polarities based on the direction of the loop. So the current B to C, two currents are flowing. One is from B to C, I2 is flowing, plus to minus. Similarly, I3 is flowing. Similarly, plus minus, there is a voltage source. And at 3 ohm resistor, I2 is flowing here plus and minus. Similarly, you can observe the loop ADC, sorry, ADE, CBA. I3 is flowing, so that plus minus, again here, plus and minus. Clear? So here I1 is flowing, Here also downward I1 is flowing. Just for your reference, I am writing. So I2 is flowing in upward direction at 3 ohm resistor. I2. Okay. So now we write the equations just by applying the KVL. So apply KVL. Before that, once again I repeat the steps. The steps is to give name for the nodes, give name for the nodes or junctions. Once after giving the name, give loop direction along with the current. Once after giving the loop after a loop with the help of current, then mark the polarities based on the direction of the current. Then apply KVL by marking first polarity or second polarity. I am considering second polarity. So just by marking the second polarity, so I am writing the equation of KVL at loop 2, that is BCFGB. So how can you write now? Minus, I'll start from B to C. Minus 1 into, so which current is flowing? I2 is flowing in this direction, I3 is flowing in this direction. I can write the difference of this. That is minus 1 into I2 minus I3 is flowing. Similarly, there is a voltage source in between C to F, so that I'll directly write minus 5. Then G to B minus 3 into I2 minus I1 is flowing. You can observe I2 is flowing upward and I1 is flowing downward, and the reference loop is a second, so that minus 3 into I2 minus I1, that is equals to 0. So now I'll simplify this equation. So just simplify to get the unknown values. So, so once after simplifying, so I'll rewrite this equation as minus I2 plus I3 minus 5 minus 3I2 plus 3I1 equals to 0. So minus 5 I'll send on right side. So again, minus I2 minus 3I2 is nothing but minus 4I2 plus I3 as it is plus I3 plus 3I1. But what is the value of I1 here? I1 is nothing but 1 ampere plus 3I1. That is nothing but 3 into I1 value is 1 minus 5 equals to 0. You'll get 3 minus 5 is minus 2. We'll send that to the right side. It will become minus 4I2 plus I3. So plus 3 minus 5 is minus 2. Right side, if you send that my right side, it becomes plus 2. This is equation number 1. You know that I1 value you already know, that is 1 ampere. So that you will neglect this loop. By neglecting that loop, apply KVL to rest of the 2 loops. Similarly, you apply KVL for the loop 3. That is nothing but apply KVL to loop 3 is nothing but in clockwise direction. I will name A, D, E, C, B, A. I3 is flowing. Okay. So I'll mark the polarities based on the direction of current minus, minus, minus. I'll write the equation now. So minus 5 into, if you want, I'll change the ink color also for your reference. So you can write minus 5 into I3 is flowing from D to E, E to C no current, C to B again minus, which current is flowing? I3 minus I1. You can observe now I3 minus I1. I2. I2 is flowing in this direction, I3 is flowing from C to B, so that I3 is the reference. Minus 1 into I3 minus I2. Come here again. B to A. I3 minus I1 into 2, and polarity is negative, so that minus 2 into I3 minus I1, 1 equals to 0. But what is the value of I1? 1 ampere. Remember that. Keep that in your mind. So I'll simplify now. Minus 5I3 minus I3 plus I2, that is minus into minus is plus, minus 2I3 minus into minus plus again plus 2I1 but value of I1 is 1 equals to 0. So now simplify this equation. You can get minus 5i3 minus I3 minus 2i3. I1 6 plus 2 8 plus I2. So I'll write I2. So 516 to 8 minus 8i3 equals to, so I will send on right side, it becomes minus 2, and this is equation number 2. So now we are getting two unknown equation, but one value you already know, that is the value of current I1 is 1 ampere, so that you're finding another two loops current by neglecting that loop. By neglecting this loop, you're applying KVL to the rest of the loop. So now we'll solve the equation with the help of calculator by keeping this to the equation mode, that is equivalent mode. So we'll be having two unknowns, so that consider the two unknowns. Minus 4 equals 1 equals 2. Similarly for the second equation, 1 equal minus 8 equal minus 2. We'll get the values of current, that is nothing but I2 is minus, I2 is, write it here. So I2 is minus 0.4516 amperes. Similarly, I3 is 0.1935 amperes. So these are the branch currents, or else the loop currents. Similarly, you can find the branch currents, that is I1 minus I2, I1 minus I3, I2 minus I3, just by substituting these values. So this is how you need to find the, this is how you need to solve the mesh analysis problem, that is a super mesh analysis problem. So this is a super mesh analysis problem, so that where there is a current source, you just neglect that loop. Suppose if the current loop is in between two loops, then you neglect that current loop branch, apply KVL. So what I have done here, I am neglecting this current loop branch. So this current loop branch we are neglecting, so that you already know the value of this current, so that you are neglecting this loop, applying KVL to these other loops. So like that you need to find the unknown values of current. So I hope you are understanding the problem. So if you're having any doubts regarding this problem, please do write in a comment box. Thank you one and all for watching this video. If you're having any doubts, please ping, so that I can able to solve your doubts. Have a nice day. And if you like the video, please do subscribe and share as much as possible. Thank you once again. Have a nice day.